Hello everyone, I am Brenda from Sri Venkateswara College of Engineering. In this video, let us discuss about the epsilon NFA in a theory of computation. Okay, what is epsilon NFA in a theory of computation? When we come to the epsilon NFA, it is a fundamental concept in a theory of computation. In this video, we will delve into the definition, construction, and applications of epsilon NFAs, exploring their significance in a formal language recognition. First, introduction to the finite automata. Finite automata are mathematical models that represent states of machines with a finite number of states or transitions. When we come to the machines, it has sequence number of states and many more number of states in a different working process. We have to represent each state of a machine in a finite number of states and transitions of the states as well. And types of finite automata. When we come to the types, there are two main types. The first one is deterministic finite automata and non-deterministic finite automata. This NFS allows for multiple transitions from a single state. It means in a single state, multiple transitions has to take place in an NFS. When we come to the definition of epsilon NFS, let's come to epsilon transition. An epsilon NFA is a type of NFA that includes epsilon transition denoted by epsilon. These transitions allow the automation to move from one state to another without consuming any input signal. It means the transition has to take automatically and it can move from one state to another state before or without consuming any input signal. Next, non-deterministic automata. Epsilon NFAs are non-deterministic because they can have multiple transitions from a single state, including epsilon transitions, making it possible to follow different paths for the same input string. The next, constructing epsilon NFA from regular expressions. When we come to the regular expressions are powerful tools used to define patterns in strings. Each regular expression can be converted into an equivalent epsilon NFA. The next one is construction of regular expressions. The construction process involves creating a state for each sub-expression in the regular expression and adding epsilon transitions to represent continuation, attenuation, and the closure. Next we come to conversion of epsilon NFA to NFA. First one is epsilon closure. The process starts by completing epsilon closure of each state, which includes all states visible from the current state using only epsilon transition. The next one is transition function. The transition function of the NFA is updated to include transitions from each state to its epsilon closure for every point input signal. The next one is final state. The final state of the NFAs are all the states whose states will contain at least one final stage of the epsilon NFA. So epsilon NFA and NFA. The first one is acceptance. Both epsilon NFAs and NFAs accept the same language, meaning they accept the same set of input strings. Power. When we come to the power of epsilon NFA, all the epsilon NFAs have epsilon transitions. They are considered equivalent to NFAs since they can be converted to NFAs with the same language recognition capability. The next one is application of epsilon NFA. The first application is lexical analysis. Epsilon NFAs are used in lexical analysis to recognize tokens in programming languages, identifying keywords, operators, and other language concepts. The next one is regular expression engine. Epsilon NFAs are used in regular expression engine that and they are fundamental concept in various processing and analysis. Conclusion and future considerations of epsilon NFA. Epsilon NFA provide a powerful tool for understanding and working with regular expressions and finite automata. They are essential for various tasks in a computer science, such as lexical analysis and regular expression matching. Future research focuses on exploring epsilon NFAs in more complex computational models and their applications in areas like machine learning and natural language processing. And thanks for watching.